Okay, so now we're looking at so lower near water, so latitude, ocean currents, winds, air masses, elevation, relief, and its closeness to water. And so this is textbook stuff that we were looking at the other day, and just we'll look at a few different things that can be drawn from it based on your findings from yesterday. So the first thing we're looking at is the Gulf Stream and the North Pacific Current. Okay, so we're going to be talking about the lovely little city of Prince Rupert and the lovely little city of Cartwright, Newfoundland and Labrador. Okay, so the North Pacific Current comes across the Pacific Ocean, and as I see this right now, I drew that a little too far north. That's okay, what the heck. So I always think of it striking, let's say, southern Washington State, somewhere around Oregon, somewhere in this range here. The line's not amazing, but it doesn't really matter. So we'll call that the North Pacific Current. Okay, relatively warm ocean current that splits. Obviously, it runs into a continent. When it runs into a continent, it doesn't have many options, so it's going to split and form two ocean currents. Obviously, overall ocean temperatures further up here will be colder than ocean temperatures. You can't see me, but I'm drawing down here, California, northern Mexico, Baja Peninsula, all the rest. So we end up with the warm Alaskan current here. Okay, and you also then end up with similar temperature water, obviously, just going into warmer ocean water, which is going to be the cold Californian current. Okay, so a warm ocean current, I'm thinking you're visualizing it already based on lake effect snow and all the rest. Warm ocean currents, any winds blowing across here will do two things when they hit this warm ocean current. They'll increase in temperature and they'll increase in humidity. Then when they hit land, cool condense and fall. It does also help that this land is fairly mountainous, so it'll create elevation-based orographic precipitation as well. Our opposite side then is we're looking at this lovely little city right here, which is Cartwright, Newfoundland and Labrador, and Prince Rupert in BC. So if we're at Cartwright, Newfoundland, we've got two major ocean currents affecting that as well. So we've got what's known as coming straight down here, let's say in between Greenland and Baffin Island. You've got the cold Labrador current. Okay, and coming up the east coast of the United States here all the way across, and then ending up on the far side of the Atlantic Ocean here, we have what's known as the Gulf Stream. If you ever get a chance to go to Bermuda, it's a warm enough climate for actually being fairly far north, and that's strictly based on the warm ocean current going by. It happens to be right in the middle of the stream. So, okay, so we got a collision right here, and what's cool about this, just visually, why is this part the foggiest place in Canada? Well, you got this warm ocean current almost colliding with a cold ocean current. Any water vapor that's in the air above is instantly going to hit cooler water and just simply condense. So it's a region that contains a lot of water vapor in the air and condenses when it hits there. However, these two cities are kind of interesting in the sense that they're both at 54 degrees latitude. So Prince Rupert and Cartwright. They're both at 54 degrees north, okay, and Cartwright is also 54 degrees north latitude. So when you're at the same latitude, you receive the same amount of insolation, so should, similarly have fairly similar climates, basically the same climates, that type of thing, if latitude was the only determining climate. So if they're at 54 degrees latitude, Prince Rupert has, I shouldn't say negative, but okay. Prince Rupert has an average temperature of 7.5 degrees. Take all the 12 months, put them all together, you get an average, mean average of 7.5 degrees. Whereas Cartwright has an average temperature of 0 degrees. And this would be Celsius. So, well, how the heck, same latitude, all the rest, how the heck do you have very different average temperatures for two places that should, in theory, have very similar climates? Okay. Then when you look at precipitation numbers, and I'm going to get this wrong. Well, let me get it right. Give me 1 second. When you're looking at their average precipitation numbers, you get, it should be here, 1 second. Of course, it's taking me longer to find it than it normally does, which is totally fine. So that's there and that's there. And so what you get is you have Prince Rupert being the rainiest place in Canada, which gets over 2,000 millimeters plus of precipitation throughout the course of the year, whereas Cartwright gets way less than that, averaging only around 1,100 millimeters of precipitation per year. So you have two places at 54 degrees north latitude, one place that is 7.5 degrees warmer on average throughout the year than the other place, and one place receives, let's say, double the precipitation. Prince Rupert must be a miserable place. Must rain about 250 days a year. And so this is principally caused by the two different ocean currents. Or, well, one reason, I guess, when the southwesterly winds kind of blow this way, and there isn't a ton of precipitation left, let's say, by the time it gets there, but that's not necessarily true as well, as the air mass is mixing and colliding. And one dominant factor is these two ocean currents. So winds passing over here would hit this warm Alaskan current, or pass over the warm Alaskan current, pick up moisture, warm up, hit land, cool, condense, and fall. The same, any air swirling around here, this kind of maritime polar air mass, the colder water, colder ocean current is not releasing that water vapor into the air. And if you're not releasing the water vapor into the air, there's nothing to cool, condense, and fall when you get to Cartwright, or in this general area. There's nothing to cool, condense, and fall. Okay, and so if that's our basic idea between Prince Rupert, Newfoundland, Gulf Stream, North Pacific, we have Vancouver, BC, and Regina, Saskatchewan here, right? So when you look at Vancouver, Regina, and we can even add in Toronto here. When you look at Vancouver, Regina, and Toronto in terms of their precipitation levels throughout the year and their overall average temperature, you get very different numbers. So in Vancouver, you'll get a precipitation number of roughly 1,200 millimeters. So I can just maybe do this at the bottom here. So if you have Vancouver, Regina, and Toronto, right? So you'll have Vancouver has about 1,189 millimeters of rain. Average temperature in Vancouver of 10.4 degrees. Okay, whereas Regina then will have 390 or 400 millimeters of rain, and an average temperature then, just so you don't get confused with the negative signs, an average temperature in Regina of 3.1 degrees Celsius, of course. And Toronto then has an average precipitation of about 800 millimeters of rain, and an average temperature then of 8.2 degrees. Okay, so I think those numbers absolutely drive home the point of the overall thing here. The differences between a maritime, a continental, and a modified continental climate. So Vancouver being next to water based on its previous talk where it had water has the ability to hold on to heat better than land, and takes longer to swing in temperature to the warm side or to the cold side than land does. This water is constantly keeping the climate in Vancouver moderate, right? So it's keeping summer temperatures cooler, and it's keeping winter temperatures warmer. So it's creating less of a temperature range from the summer highs of the high teens to the winter lows of the single digits. Whereas Regina would have summer temperatures in the high 20s, and winter temperatures, geez, it could be in the low negative 20s. Toronto will have summer temperatures then in the high 20s as well, and winter temperatures just below zero, let's say, I don't know, the -5s, -6, -10s. And that's all principally driven by the presence of water. So being beside a large body of water, Vancouver will have a very maritime climate, moderate temperature swings, and lots of precipitation, highest number by a long shot, right? Whereas Regina, smack dab in the middle of the country, as well on the east side, or the rain shadow side, let's say a little further away, but on the rain shadow side, or the leeward side of this whole western Cordillera, row after row after row after row after row of mountains. This would be your definition of a continental climate. Okay? And Toronto then, being in this region, which has not an ocean beside it, but a ton of water, about as much water as you could ever possibly get. Forget the Great Lakes, but even this pockmarked surface of the lakes here. But the Great Lakes have a massive impact on the climate of Toronto. They're known as what's called a modified continental climate. And it's a modified continental climate because it experiences some of the impact of the water, obviously not as much as a maritime climate or a maritime climate, but a lot more than Regina, just simply based on the modifying factor of this water. So this should be, a maritime climate should have tons of precipitation, which it does, and relatively warm temperatures. Continental climates would have very little precipitation and a huge swing in temperature from the summer highs to the winter lows, whereas a modified continental climate then would have somewhere in between in terms of precipitation, because the water is constantly releasing water vapor and it's going to cool, condense, and fall, and then some swing in temperature. If you look at these two numbers, they basically are right in between the maritime and continental. The modified continental numbers fit right in between because of the presence of not a ton of water, but a lot of water.